You're all welcome to week 5 of the course. In the past 4 weeks, we've spent a lot of time getting to understand the principles and the foundations of epidemiology. We talked about this from a public health perspective, clinical practice. We also got into the different measures of frequency that we use in epidemiology. We also started talking about measures of association, which we will revisit when we get into more extensive discussions about the different epidemiologic study designs. The reason why you would see that it looks like we're kind of going a little backwards, but it was just because I wanted you guys to get the basic foundations, and then we now go on into the core of epidemiology. So this week we're going to talk about data sources that we typically use in health epidemiology, and also introduce you to the various study designs. While we will not discuss each study design in depth, I'll just give you a basic overview, and then starting from next week and in the subsequent weeks, I will focus more time on specific case study designs, because that's really what we want to make sure that you get and understand from this course. And then this should also provide some basis for you to complete your final project. So for data sources, I'm going to briefly talk about the importance of data in meeting most of our epidemiology and public health goals. It's going to be a very short section of this presentation, but we will spend time doing some exercise on the discussion board about data sources. What we need to know is that data sources, or data in general, are essential for epidemiology and health as a whole. Based on all of the discussions we've had on the discussion board and all of the ideas a lot of you have shared, we see that we cannot do all of this without having some kind of data. And this data could either be quantitative or qualitative. But it's the reason why we say it's essential is that it provides the information necessary to identify and understand problems in communities. It can help us effectively select and deliver prevention programs, and also to find out if these programs work. So as you can see, if you remember what the goals or the objectives of epidemiology are in public health, you would see that all of these align with the reasons why data are essential. And you notice I say data are essential because data is actually the plural form of datum, which would be singular. So data, when you use data, although most times you hear it say, people say the data is clean or the data is available, it's actually data are available because you're talking about it in plural forms. When we talk about data sources, there are two major data sources. I'm going to start with secondary first, and then I'll go into primary. And the reason why I'm doing this in reverse order is that the second one actually leads us into what we'll be talking about in the second half of the week, which would be the different study designs. For secondary data sources, these are usually data that are already readily available, and sometimes they may be collected not necessarily for research purposes. They might just be routinely collected data or data that's already there, and when we actually observe some kind of trend or pattern, we can refer to these data sources to enable us identify potential explanations for what we're seeing. So some examples of secondary data sources would include vital statistics. These would be like death and birth records. And again, the other thing you need to take into consideration is that from a developed world perspective, these data are available, but in some underdeveloped countries or areas where there's a lot of war and there's no accurate record keeping, these secondary sources may not be available. And that's while I don't want to go into detail about that in this course, this is something you should keep at the back of your mind when you're actually developing studies, or while you're attempting to address the questions that I pose on the discussion board. Okay. Other sources would include census data as well. The same issues that I just mentioned about vital statistics would apply here when you're looking at non-developed countries. Others would be medical records. This is predominantly used in a lot of the peer-reviewed research publications that you see on PubMed. And this could be electronic or paper. It could be from schools, surveillance, registries or databases that are already pre-existing. Even the health department too. When we talked about routinely collected data, sometimes we can also go to the health department to collect this data to answer any of our questions. The upside to using secondary data is that they're more cost efficient when compared to primary. This is not to say that it's relatively cheap, but when you compare it to trying to get primary data sources, this is actually more cost efficient because the effort has already been put into collecting the data, right? So maybe you probably just need more time to do the cleaning for the purposes of why you need the data. It's also time saving compared to primary. It's not to say that you don't spend any time doing work on it. It's time consuming, but it's actually more time saving when compared to primary. The downside to secondary data is that it can be inaccurate. Again, remember, like I stated earlier, most times these data are not collected for research purposes. They're just being collected, so there might be certain data points that are missing, which is one of the downsides to using this data source. But from a statistical perspective, there's a way that we could actually adjust or address these issues. Having talked about the secondary sources, I'll talk about the primary. Examples of primary data sources would be, before I even tell you about the example, primary data sources would be any data that you as the researcher or the investigator collect yourself. So it's primary because you are the main person collecting it, right? Even if it's not you as the investigator per se, but your team is actually collecting it firsthand as opposed to getting it secondhand. Examples would be like surveys, either maybe those you hand out to people by the roadside, or those that are sent electronically. There could be surveys that are sent from the state or local levels. Some of this could be personal interviews as well, whether structured or open-ended. Others would be like focus groups, and we will go into these in a little more detail when we get into the different study designs, but I just need you to know this. Some of the downsides and upsides to using the primary data is that the upside is that it's likely to be more accurate because you are actually collecting data on what you are interested in. The downside is that it's more time consuming and it's more expensive, meaning you're actually utilizing more resources to collect the data. So let's say you're actually using people to conduct the interviews, you're using human resources, meaning you have to pay people for this, you need to find funding for it. If you wanted to do the statistical analysis as well, like coding, you have to pay people to do stuff like that. So compared to the secondary data sources, it's more expensive and more time consuming. So for data sources, that's pretty much what I'm going to talk about. You read about a little bit more about data sources in your textbook. However, to make sure that you actually do grasp the concept around data sources, I have a discussion board exercise where you would actually identify the data sources for a specific health discipline of your choice. And you need to take the time to highlight what the advantages and disadvantages of that data source is. So I need you to think outside the box. Through your readings, through additional research work, you identify different data sources, and then you should be able to analyze yourself what could be the potential downsides of using those data sources. Okay, and then we'll all take time to kind of critique each other's data sources, and then we'll go from there, and that would help lead us into the different study designs that we do have. So for the epidemiologic study designs, I'm going to address this from the point of view of the branches of epidemiology. Remember, I stated that there are two main branches of epidemiology, which would be descriptive and analytic epidemiology. Descriptive epidemiology is really the branch that focuses on describing based on person, place, and time, right? You performed an exercise on that, both on the discussion board and in your homework assignment. So remember that. Remember, we also said that it can help us generate hypotheses for further analysis. It can show correlation, not causation. I will highlight that again. And it's also useful in enacting and evaluating surveillance and disease control measures. This you should already be familiar with. When we talk about it showing correlation, the correlation is usually more of a linear relationship. That's really what you're able to get out of it, and not necessary, which is a form of association, but not necessarily, the relative risk, right? So you can estimate relative risk or odds ratios using the study designs in descriptive epidemiology, and I'll go over that in a few. For the second branch of epidemiology, which is analytic epidemiology, which we really haven't gone into much detail on because this first half of the term we're spending looking more at the descriptive epidemiology, because that, again, like I've stated several times, sets the foundation for the analytic epidemiology. It's actually the branch that focuses on understanding the why and how. So it actually helps you test the hypotheses that were generated in the descriptive epidemiology. You're also able to establish association here, which is a step further than simply showing a linear correlation, right, which is applicable to descriptive epidemiology. And there's also the possibility of establishing causality with analytic epidemiology. However, there are certain criteria that must be met for you to be able to establish causality. Having said that, when we talk about the different study designs, as you can see from the slide, you see the order in which it goes. So I'm going from looking at the direction of the arrow from the top to the bottom. This goes in order of the ability to establish causality. So starting from being able to generate hypotheses all the way to being able to establish causality. So as you keep going down on this list, you continue to move towards more rigor and also the gold standard for study design. So following the direction of this arrow here, the lower you go, the more advanced the study design is, okay? And you're more likely to establish causality. You can also flip this around, meaning that the higher you go, the more rigorous and the more of a gold standard that study design is. Okay, so I'm going to try to categorize this using two slides with the hopes that you would get what I'm saying. So when we're talking about epidemiologic study designs, we have them in two categories. They're either observational or experimental, right? So again, remember I started off with telling you that there are two main branches of epidemiology. And under those two main branches of epidemiology, there are two main categories in which the study designs fall. So they're either observational, meaning that the investigator doesn't manipulate anything. The investigator just observes what happens in the natural environment. And experimental is where the investigator actually controls what happens in the environment. Okay? The key difference between both categories is randomization. You need to remember this. I'm going to try to hammer this several times with the hopes that over time you will get it. Again, there are two main branches of epidemiology, which is descriptive and analytic. For epidemiologic study designs, there are two main categories they would fall under. Either they're observational and experimental. Examples of observational studies would be case report, case series, ecological studies, and cross-sectional studies. And all of these would fall under the descriptive arm or branch of epidemiology. They're all observational. What this means is that for the descriptive arm of epidemiology, there are no experimental study designs. They're all observational, right? Meaning the investigator does not manipulate any factors. He or she just observes what happens in the natural environment. Under the analytic arm of epidemiology, we have study designs that fall under both observational and experimental. Observational designs would be case control and cohort studies. Okay? Experimental designs would be randomized controlled trials and community trials, right? So randomized controlled trial, like we said, is the gold standard. And the key difference between both categories is that one involves randomization, and you can only randomize in an experimental setting. Here's another way I try to put it. Hopefully this might help some people, because I know some people are more visual. You can see that the top line shows the branches, right? You have descriptive and analytic. Then the second row shows you the different study designs, and I see that I group them as observational and experimental. Under the descriptive column, all the studies are observational. Under the analytic columns, we have a few that are observational, and then of course the one that is experimental. I hope this kind of helps you guys understand it. One other point I like to note is that there might be some textbook where you see that they put cross-sectional studies as more of an analytical study design. There's still a debate about that. But if you were to ask me and most of my other colleagues, it rightfully falls under a descriptive epidemiologic observational study design as opposed to analytic. And you would see in next week's exercise when we would actually spend time looking at cross-sectional studies, because it's also another way to say or call a survey study. It's really looking at exposure and outcome at the same point in time. Okay, so this slide here kind of, is a consort diagram that kind of shows you how to make a decision as to which study design to use. As you can see on the left, it says if the investigator assigns exposure, right, meaning that the investigator actually manipulates factors, then it becomes an experimental study. If the investigator does not manipulate any factors, meaning that he or she observes what happens in the natural environment, then it's an observational study. So going back to the left side of the screen, if there is randomization, then it's a randomized controlled trial. If there's no randomization, then it's a non-randomized controlled trial. If you look at the screen that talks about the side of the screen that talks about observational studies, if there's a comparison group, then yes, it will fall under the analytical arm, right? If there's no comparison group, then it's a descriptive study. So again, this is an example of where I told you that, sometimes some textbook might refer to cross-sectional designs as part of analytic, and some would also call it descriptive. So if you look at the previous slide, you see where I put it kind of hanging somewhere in between, but it's mostly really a descriptive study design, if you were to ask me my opinion. Okay, so let me quickly go over these various study designs and just kind of give you a brief overview of what each of them entails. So for case reports, case reports be reports on only one subject. So say, for example, a patient goes to see a doctor and no one's really seen that particular condition before. It's a rare condition, but the doctor decides, this is actually worth noting. Then they would write a report about that specific condition and how it was treated, just to kind of, set the tone or enlighten other clinicians in other areas of the world about that particular condition. So usually it's just a case report on one subject, most of the time on one subject, or a few subjects, maybe about 1 to 3 or 1 to 5. It just describes the unusual feature, and there's really no control group. You're just describing what they've seen about the person, the place, the time, and whatever it is that you found there. The thing is that it usually allows for the generation of hypothesis. Again, if you remember, this aligns with what descriptive epidemiology allows us to do. It's usually very quick to conduct because there's really not a lot of resources being utilized, and it's relatively inexpensive compared to the other study designs. So now notice that we're starting all the way from the lowest on the hierarchical scale. This is the lowest, right? Then we go to what we call case series. This would be a few cases, typically greater than 5, but not large enough to call it a big sample. It's usually a series of the same particular unusual feature or condition that we observe. Same thing, there's no control group. Same characteristics. It allows for the generation of hypotheses. It's usually quick to conduct and relatively inexpensive when compared to the other study design. So as we keep moving up the scale, then we have what we call the ecologic studies, and some books are called ecological studies. It's all, call it whatever you want, but it's really more of a study design that looks at aggregate or group of individuals, by geographical area. So an example would be maybe a graph that shows the socioeconomic condition versus percentage of smokers in each county, maybe fat consumption of breast cancer by country. So it looks at people in groups, right, based on geographical area and maybe over a particular period of time. So it looks at trends in time. It never goes down to the individual level. All right. So what are the advantages of this study design is that it allows for the generation of hypotheses. It's relatively quick to conduct because you're using pre-existing data. So you see why I had to talk about the different data sources before I got into the various study designs, because a lot of the descriptive observational studies are based on pre-existing data, right? That's how we're actually able to come up with hypotheses that we can generate. So if you don't have a reliable data source, then that would actually help you determine which approach to take to answer your research question. So if there's no data, then you would most likely need to go the primary route, where you would actually go collect the data yourself. If the data is already pre-existing, then we can look at these data sets to generate hypotheses and help us make decisions in terms of whether to implement programs and things like that. The other advantages would include that it's relatively quick to conduct, less expensive when compared to other advanced study designs, and you're actually able to show correlation. Again, remember, correlation in this sense would be more showing you a linear association or linear relationship between variables, as opposed to telling you, measuring a measure of association like you would do for relative risk. What is the disadvantage of ecological study designs is that there's something called what we call the ecological fallacy. And this would be an erroneous or inaccurate assumption or conclusion about an individual based on aggregate group data. So in layman terms, this is almost like you coming up with a stereotype simply because the data or the trends have shown that a particular group of people, tend to have X, Y, and Z. That doesn't necessarily mean that every single person who falls under that group has the condition. So this is where we fall into that issue of an ecological fallacy. That's why when we tend to use the study design, we need to be very careful with the way that we interpret our findings. And next week, I will go into this in more detail with you guys. Okay, so the next study design we will go to be the cross-sectional study design. And like I stated earlier, this is also called a survey study design, which a lot of you will probably be very familiar with. In this particular study design, cases or subjects are usually looked at one time, right? So you come in at a particular point in time, collect the data, and you look at the cases, the exposure, and the outcome at that particular point in time. We don't look at a period of time. So let me use an example. It means I just come into a class and say, okay, I'm going to take a survey of how many people who develop a particular health outcome, right? I come in and say, okay, how many people have asthma in this class, right? And then maybe I also look at the temperature in the class at that time and want to know how many of them at that point in time have an asthma attack, right? So I'm collecting my exposure and my outcome at that particular point in time. So it's done simultaneously. Example of how this is typically done, like I said, would be like surveys, interviews, self-completed questionnaires, whether electronically or in person. And the other factor that you would always want to take into consideration when you're thinking about cross-sectional studies is that you want to take response rates, right? Because if you don't have a high response rate, then you run into the issue of something similar to the ecological fallacy we talked about differently, but that's not really what it's called here. But now it's underreporting, and then you might end up exaggerating your study findings because the numbers that you have are not representative of the population of interest. Again, in week 6, in week 6, that will be one of the key areas that we would focus on. You will perform your own exercise, and we'll talk about it in more detail because this seems to be one of the most frequently used study designs by people who just want to quickly get a quick answer to a question because of funding purposes. So while it's also time consuming and expensive, it's relatively inexpensive compared to conducting a randomized control trial or cohort study and maybe a case control study. Um, Advantages, same thing, will be the generation of hypotheses. Again, remember all of these follow the same advantages of descriptive epidemiology. And one of the major disadvantages is that you're unable to assess seasonal variations. You know why? Because like I said, you come in and you collect the information at that particular point in time. You don't care what happened 30 minutes ago, 60 days ago, or what is going to happen 30 minutes from now or 60 days from now. You're just coming in now, collecting this information at this particular point in time, and you're going to make your conclusions based on your finding. So as you would see when we start working on this, sometimes the way people respond to surveys is also dependent on their moods at that time. So is that an accurate representation of what you really want to measure? Maybe not. But again, these are all the downsides to these study designs that you have to take into consideration when you're deciding on which of them to take up. Here I have a few examples. I think on the next 3 slides will be a few examples. to kind of guide you on ways to identify which study design will be applicable. These are research studies that have been published, and they're actually available via PubMed. But as you can see, I took the abstracts from these studies, and as you can see from the abstract, you can kind of guess or determine what kind of study design was applied. So let's look at the first one, for example. It says routine data were collected on the height and weight of 134,577 children participating in the obligatory health examination at the time of school entry. That's one clue right there. In Bavaria. In a subsample of 13,345 children, early feeding, diet, and lifestyle factors were assessed using responses to a questionnaire, right, completed by parents. The prevalence of obesity in children who had never been breastfed was calculated and compared with breastfed children, right? A clear dose response effect was identified for the duration of breastfeeding on the prevalence of obesity. Similar relations were found with the prevalence of being overweight. Other factors were also looked at. It was concluded that in the industrialized countries, promoting prolonged breastfeeding may help decrease the prevalence of obesity in childhood. So based on these few things that I highlighted, can you guess what study design this was? If you were to ask me, this is a cross-sectional study design. One, because, excuse me, the data was collected at one point in time, right, where they looked at the exposure and the outcome. It was done using a questionnaire. The measure of frequency that we're actually able to obtain was prevalence, right? And remember, prevalence looks at all cases, and you can measure point prevalence, period prevalence, right? We can measure prevalence here. So with all of these factors that you've identified, without even reading the entire study, the clue that comes to mind is that this employed a cross-sectional or survey study design. I have a few other examples on here. You can review them and then we can talk about them as well on the discussion board. I have a cough right now, so I'm running out of breath because I'm not feeling too well. So I'm going to stop here without going into detail. I just want you to do this as your own personal exercise and then see if you can identify what study designs this employed, and then you can cross-check or reference check them with the original article via PubMed. Here's two more, and I will end this presentation here. Again, it's a very short presentation. I'm not feeling well, but I just wanted to make sure that I had something to connect with you all so that you understand the direction in which we're moving this week. I will see you on the discussion board when we start talking about the different data sources that we would use for our health topic or health discipline of interest, and that would transition us into next week where we'll talk about study designs in more detail. All right, talk to you soon.